So for number 7, we do have the table that gives the gross domestic product in billions of dollars for the United States from 1940 to 2005. So it looks like in 1940, the gross domestic product for the United States was 837 billion, and in 2005, it was 12 trillion, meaning thousands of billions. That's a lot of money, and that's a gigantic increase. So we're going to plot the data with respect to the number of years past 1940. And so again, we need to remember that having these numbers be our x values would be a bad idea, because they would make a nasty equation because they are so big. And so we do need to add a column of years since 1940. And so for that, it's going to be 0, 5, 10. I can do the little trick I showed you in class. If I believe these are going to continue to go by 5s, they go by 5s all the way to there. And then it's 61 years later, 62 years later, 63 years later, 64, and 65. So now I have two columns that I can make a graph from. And again, I'm going to do this fairly quickly compared to how I did it in the lesson. So if you want more practice of this, go back to lesson 2.5. And so I'm going to say insert chart, and I do want a scatter chart, not a line or a bar chart like it is in this case. So, or column chart. So I need to find a scatter chart. I don't know why that looks a little bit different today than it did the other day, but oh well. So we are asked to find both a linear and a cubic model for this data. So again, the way that we do that is we come to Customize, Series. We say we want to add a trend line. There's our linear model. And to have the equation on there, we need to come down to Label and say Use Equation. So here's our linear model. I can just copy it straight from here, paste it here. And then again, to get this menu back over here, I have to double click inside the graph. Then we're going to go back to Series to get a cubic. We already have a trend line selected. A cubic is a polynomial to the power of 3. So we can see that that power of 2 doesn't fit the data super great. Let's try to the power of 3. That's quite a bit better, actually. So you can see that it went up pretty good and then kind of slowed down for a while and has gone crazy lately. So very much gross domestic product coming out of the United States. And so here's our cubic model. I believe that the cubic model is much better than the linear model. It seems to fit the data a lot better. And so we're going to use the cubic model to predict the gross domestic product for 2012. And then is there a guarantee that that will be really what happens? And so for 2012, we need to recognize that 2012 is how many years past 1940? 72. So our x value for this equation is going to be 72. And so we're going to come to Wolfram. I guess I could have just done it in the window over there on the side, but let's go ahead and do that since that's being slow. We will paste our equation into Wolfram. And remembering that we need, what do we need for the years past 1940? 72 is going to be our x value. So I've got to say times 72 there. Here I've got to put 72 in parentheses so that it gets squared. And over here I need to put 72 in parentheses so that it gets cubed. Wolfram is taking his time this morning. I'll pause our video while we wait for Wolfram. Well, it seems like Wolfram's website is down for the moment, so I went ahead and used a different calculator to compute that, and I ended up with 17,944.28. So 17,944.28. So what we have, everyone, is that for Part C, the gross domestic product for the gross domestic product in 2012, this model predicts that it's going to be $17,944 billion. Projected to be 17,944,280,000,000. And so there's that number spelled out, everyone. That's a pretty gigantic number. So again, this is the gross domestic product for the entire United States, that's a huge, ridiculous amount of money. So at any rate, everyone, I hope this is helpful, and I hope you have an awesome day.